We are here at the Smart Factory at the School of Mechanical Engineering and Business Economics. And with me is Franz. Franz, can you introduce yourself a little bit?
Yes. I am the head of the Institute of Production Engineering, and we have 4 departments, and the newest one and a very fantastic initiative is the Smart Factory at TU Graz.
So how did it all start with the Smart Factory?
Yes, it is starting 4 years ago approximately, and now we have opened the Smart Factory this April, and you see, and we will have a look to all these facilities here. We have modern equipment in all fields of digitalization.
Okay, thank you very much. Let's now move over to the head of the Smart Factory, Mr. Rudolf Pichler. I just introduced you, Rudolf, so maybe you can introduce what's going on here in the Smart Factory. What are the topics of the Smart Factory?
Yes, to tell you what is the Smart Factory about in a nutshell, I took out 4 major topics, and this is on the screen visible here. First, we deal with and we work with agility concepts, and I think this is quite unique because we do not only talk about agility, we simply show how you can really do it physically. And later on I will show you some examples for this agility concept. As a second topic, we are very proud of to do seamless data integration. Smart Factory, of course, is about Industry 4.0 or the digital transformation, and we have to deal with all the challenges, all threats also, of course, and that is why we made our thoughts about how could we do this integration and how also to be secure. And this leads to the third major topic. This is data security. Not only to tell about, yes, we need awareness because of security. We also show how you can do this with soon concepts, with data control and much more. And last but not least, we are very proud, and you can see this on these 2 antennas on top of coming from the ceiling, these 2 white boxes. This is the antennas for our 5G concept here. We are the first university in Austria that has implemented such a concept. Yes, so that's in a nutshell.
It looks like there is a lot of smart. Could be also at the School of IT or software. That's kind of strange because I need to ask Franz about this. That's also a factory. So we not only have smart stuff, but also real machines, right? Let's have a look at this
Yes, please come. I will show you some of the modern machines. They are really expensive, but they are at the core of this machine. The core is the connection between the machines. The facilities are capable to give us the product, our product, a gear, a robot gear, a so-called wave gear. And these machines, turning, milling, gearing, they lead to all these parts. The parts which are the components of this gearbox. We assemble there.
So gear is produced here in the Smart Factory and also assembled?
Yes, we have, the approach is that the deepness of our production is really high, and it's a unique thing also for our Smart Factory in comparison to other learning factories existing.
So let's have a look at the assembly over there.
Yes. We are really proud of that because we had the idea to be, and as Rudi mentioned, agility is very important. So our configuration here is not rigid, it is not static, and so we have elements, so-called mobile working stations, and they are autark, they are really flexible and agile. They all have their own purpose, and at the end we have here, for instance, a really unique transportation system for shuttles.
So Rudi, tell us a little more about the agility system of this facility and the robots and what's that all about? How do you produce the gear here or assemble the gear here?
Okay, just that you get an idea what the gear is about. It consists of a lot of components. We do it in lot size 1. We do not a serious production here. but you can have this gear in 18 different versions. Yes, and this assembly station is capable to master and to check all to have it in sequence in lot size 1. So the actual configuration shows that we can especially act for this in 18 versions. But if there would be a new product that needs turning, milling and others and certain actions of assembly, we would be able, via reconfiguration of these mobile working stations. And this is rather easy because, as Franz told us, they are autark, they are autonomous.
So how long does it take to reconfigure if you want to do something new?
I think at least half a day, but then it works. And just imagine, you simply tear apart all these squared mobile working stations, you configure them newly, and one big advantage of this concept is that an energy supply is fully independent. Maybe we can see here, yes, we have got an accumulator, yes. This is for the electric energy. At the rear you can see there's a tank for air pressure, because we have a pneumatic press, for example. And last but not least, the information that is necessary for acting comes from the ceiling, yes, and this is via wireless communication.
Okay, perfect.
And
let's
this
have
makes
a look
it
over
possible.
here. So Franz, what can we see here? If I look at this here, what is this all about?
Yes, this is such a pressing station, and please have a look to this. We use also additive manufacturing. You already have an imagine of our AdLab, and the gripper systems should also be very flexible, and they are produced here in our own facility with our own selective laser melting machine. And what we can see here, we have the product and we have also the test bed for the product at the end. So the product is not really produced, it is also tested with a lot of sensors, and all this information will be stored in the cloud.
So Rudi, 5G and stored in the cloud, how does it work here? What's the advantage of 5G here, and what do you want to do in the future here with 5G?
5G is a very, very new technology, and we have to admit that it has not come so far, especially for manufacturing, as the commercials tell us. But we are in front. And what we try is to use this wireless communication with high bandwidth and low latency. And this is definitely very and highly important for image recognition and computation of image data. And maybe if you follow me, we can show you an actual project that depends on the capabilities of 5G.
Let's have
if
a
you
look
want
at this.
to follow me, please.
Quickly.
We have a collaboration with T-Systems, the daughter of German Telecom, and I received it yesterday. This is new glasses for augmented reality. Maybe you know it is the HoloLens. Yes, it's much more mighty and more voluminous, and this is a lightweight glass that makes and allows the following. If you wear it, I don't do it because I have my own glasses now, and you have a look, for example, at this machine and you see the QR code, yes? Then this glasses is identifying, yes, just take it, is identifying that you want to have information for this machine. I just take one of my, what Christian needs now is a 5G capable smartphone. You connect it, he wears it somewhere in his jacket, yes, and from here on, this is a 5G capable smartphone. From here, the wireless communication goes to our 5G network, yes, to these antennas. And then we can use, this goes very fast, and then we can use the high computing power that is somewhere in the backbone of our architecture. And he immediately, again, wireless gets back the information for this machine.
I feel already like a robot, Franz. We talk about data security. How safe is it here with the data?
Yes, it's really safe because our 5G network is a campus network. It is closed, And we have here a zone model where also different stages or zones of safety are represented. And of course, we have also a box, but Rudi, you know more about this. What is the box where we can detect
the box, the Nozomi box, yes.
Yes.
If you follow me, it's a very tiny thing here, the device, this is here. It's called Nozomi box. There are many different boxes of the same kind from different suppliers, but what is it doing? It traces the whole data traffic in here. And as soon as there is some anomaly or deviation or an untypical data package flowing around here, then there will be an alert. Yes, means there is a steady learning of the machine, of this device, and tells us everything is okay either, or the opposite, something is wrong, and please check it. Maybe you have you were attacked. Yes, and this would be the worst.
Okay.
And I think it is really of high economic importance, because we heard from a lot of companies in the last month they were attacked and they have to pay money for that, and so we have a lot of awareness to this topic at the moment.
So visitors can learn a lot about data security. For whom did you build the smart factory? Who are the customers basically?
Yes, we built it for a large wide of groups, and first of all, we like to teach our students. It is for our young people, for the young people, and also for the youngest people. We also shown it in a video during our opening ceremony for the children who keep in contact with digitalization, with robots, with additive manufacturing. But of course, we have laboratory courses here, and now we are partners of some new projects with small and medium enterprises, and they are aware of digitalization, and they learn a lot, and we learn also a lot from them.
So it's a very important initiative for the local economy. So local companies are coming here and learning and bringing in equipment, I guess, and projects are starting. So how does the future look like, Rudi? What do you think?
The future is, of course, we work as scientists, means we must bring in our own ideas, not to be led anyhow by the desires of a company, but on the contrary, of course, we need also the inputs from the companies. Yes, they trigger us to think newly or to bring new solutions, and it's always a mixture. Means we running in front somewhen, and also again not losing the capabilities of companies, because each project is also an issue of financing the whole thing. Yes.
Good. Well, thank you, Franz and Rudi, for your time, and that was an overview of the brand new Smart Factory at TU Graz.